Hello there. Here we have a second neutralization question. Notice that this is 60 milliliters of 0.5 molar potassium hydroxide, which is neutralized by 125 milliliters of H2SO4. So we're looking for the concentration here. We're going to have our three steps again, starting off with the moles of the known. Always. We want to verify our ratio. And lastly, solve for the unknown. In this case, it's for concentration. So we'll start with what we know. We know volume and we know concentration about potassium hydroxide. So let's start it off there. 0.5 moles of the KOH is in 1 liter of water, but we're dealing with 60 milliliters. Again, 60 milliliters, if we divide that by 1,000, that gives us our 0.06. This is sort of a side calculation. It's not necessarily required to be shown, but we want to convert it into liters so that we're using the same units. So we want to find out how many moles there are in this scenario. Again, we're going to cross multiply 1 times x and 0.5 times 0.06, and we're going to get 0.03 moles. So that is KOH, but also the KOH is dissociating in a 1-to-1 ratio into its hydroxide ions. So this moles is also representing the OH component, or the hydroxide. So we've got 0.03 moles of the hydroxide ion. In the case of the H2SO4, we have a little bit of a trick here, because you can see the subscript 2. And so for every one of those particles that dissociates, it will dissociate into 2 of the H pluses. So let's reverse that. If we have 2, that means, like, if we're only matching up one of the protons with one of the hydroxide at neutralization, we need half as much of the H2SO4. Again, we're trying to be equal. We don't want double this with this, so we actually need half of this. So the ratio is a 1-to-2 ratio, which means we have to take our number of moles and divide it by 2 in order to find out how many moles of the H2SO4 is required. Because for each one of these, it will yield 2 of the H pluses. So now we're on to solving for the unknown. We know the moles, 0.015 moles. And we know that it is going to be in 125 milliliters. Again, you have to show this in moles per liter. So we just do our division, moles divided by liters, to get 0.12 moles per liter. Or if you rather just use the big capital M there as your final concentration.